A chemical equation is used to show the atoms and compounds in a chemical reaction. So on the left side, you're always going to have reactants. These are called reactants, all of this on the left side. On the right side of this reaction arrow, you're always going to have products. So on the right side, these are all products here. The atoms before, the atoms of the reactants, are always going to be the same as the atoms of the products. But what's different are the bonds between the atoms. So you notice here, here's a CH4. This is a carbon with 4 hydrogens. That's called methane. And this carbon is no longer bonded to those hydrogen atoms when it's on the product side. So you have one carbon to start with, and you have one carbon to end with, but now it has different atoms bonded to it. So the combustion of methane, this is the particulate view. This is the molecular view of all those molecules. And this down here is what's called the word equation, when you have the chemical names of all of the compounds and molecules that are reacting. And you convert all this to chemical names like CH4 is methane gas. And then you have O2. This is the diatomic oxygen gas. This is the name oxygen gas. And react to form is this reaction arrow. Okay, so react to form is literally converting this reaction arrow into words. I should add that the plus signs are using the word and. So react to form means that now you're on the product side. So on the product side, there are these molecules, and the names of these are, this is carbon dioxide, CO2, okay? And then this is good old water molecule, dihydrogen monoxide would be the official name, but this is the common name, water. So here's another reaction. This is showing the combustion reaction of sulfur. So when you take sulfur and you burn it in the presence of oxygen, this is the particulate view. These are the molecular views. So you have a sulfur atom, and this combines with oxygen. This is oxygen, the diatomic. And the product side, you have, this is a sulfur now with 2 oxygen atoms bonded to it. So this is the word equation down below is solid sulfur, and that's the plus sign, oxygen gas. This is the name of this molecule, oxygen gas. Remember, that's because oxygen is a molecular element. It's present in nature always as 2. So you would never call it just oxygen atoms. It's oxygen, the diatomic. React to form. This is that arrow converted to words, is react to form. And then sulfur dioxide is the name of this compound that's formed. It's a sulfur with 2 oxygens. The di means it's a covalent compound. So sulfur dioxide, and you can confirm it's a covalent compound because it's a molecule where they're all smushed together. So this being the molecular view, this is the word equation. In the macroscopic version of this reaction, in the combustion of sulfur, most combustion reactions, and this one is true as well, produce heat. They produce heat and light. They produce some energy. And so we'll do a lot of combustion reactions in lab in a couple weeks, seeing a lot of different compounds burning and combining with oxygen. So combustion reactions can be recognized by production of heat and light. Okay, and that's what we can see on the macroscopic scale. So quick summary of chemical reactions is that we will write chemical reactions as balanced chemical equations. So balanced chemical equations. And what's different from a chemical reaction to a chemical equation is the equation has to have the atoms balanced. They're equal on both sides of the arrow. And this is because the chemical reaction obeys the law of conservation of mass. And so you have the atoms are the same before and after, the identity. So if it's a carbon atom before, it's a carbon atom after. The numbers of the atoms have to be equal on both sides. So if you had 1 carbon before, you're still going to have 1 carbon after. And what this all adds up to is that because the atoms you have before are the same as the atoms you have after, because atoms have mass, the mass of what you had before, so that's the mass of the reactants, has to be equal to the mass of what you end up with. That's the mass of the product. Conservation of mass is obeyed in chemical reactions, and we'll see that in writing balanced chemical equations. There are things that will change, like the number of molecules, because basically you'll get different reactants, and products. So the molecules will be different. And the physical states, you might start off with a solid and end up with only gases and not see what you have. This is true for combustion reactions. When something burns, you don't see anything at the end of the burning reaction. That's because everything's turned into gases and dissipated off. But what is always true about chemical reactions is that they obey the law of conservation of mass. They can be represented as a balanced chemical equation. So we'll get to that in the next worksheet, writing and balancing chemical equations. All right, let's put it to work in this worksheet, writing and balancing chemical equations.